All right, let's work on the second problem of the day. So this is LeetCode number 417, Pacific Atlantic Water Flow. There is an M by N rectangular island that borders both the Pacific and Atlantic Ocean. The Pacific Ocean touches the island's top and left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. Island is partitioned into a grid of square cells, given an M by N matrix heights. Okay. Island receives a lot of rain, and the rainwater can flow to its nearby neighbors, north, south, east, and west, if the height is less than or equal to the current cell's height, and the water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of grid coordinates results, where result I denotes that rainwater can flow from cell RICI to both the Pacific and Atlantic Oceans. Okay. Okay. And output is it's a list of coordinates. Okay. Interesting. So the first thing I'm thinking is BFS. That's just how it is. M and N less than or equals to 200. That probably suggests an O of MN-ish runtime. So the idea is that we could probably run BFS until we reach a cell that can do both. Run BFS until we can reach a cell that is either adjacent to the oceans or that we know can reach a given ocean. So we're probably going to need a data class here, I think, to make it easier. So this here is an optimization where we don't need to necessarily flow all the way to, or run our BFS all the way to an ocean. We can just run our BFS to a tile that we know can reach an ocean. Because I think the logic is that if it can reach a tile that can reach an ocean, then we don't need to double confirm that it can reach an ocean. So in that case, I'm going to create a data class. I'm going to call this cell. This is going to have a row, which is an integer, a column, which is also an integer, and it'll have can flow Pacific, which is a boolean, and also a val. Well, this might be a var. I'm going to have it as a var. Can flow Atlantic, which is also boolean. And then we can recreate the matrix, I think. So this will be an M by N operation to recreate the ocean, or recreate the tiles as our cells before running BFS on the tiles. So we can say, let's see, we're going to need a let me think. We want to create an M by N grid. I guess we could just start by recreating this. Right, we can start by recreating this. So we'll create an array which is an array of cells. The first cell will be of heights.size, and this will create an array of cells which is of size heights at 0.size. So this is assuming that the island has a uniform m by n size, which we're given that it's an m by n matrix, right? So and then in that case, we're going to have an initialization here with an index, and this index is going to say if or we can have, this will be our row, this will be our column. So we can say when row is equal to 0 and column is equal to 0, if row is equal to, or if column is equal to 0, Let me think. If the row is equal to 0, then it can for sure hit the Pacific Ocean. If the column is 0, it can for sure hit the Pacific Ocean. So we'll say if row is equal to 0 and column is equal to heights at 0.size minus 1. So this will be the corner cases, these two corners right here. Or row is equal to heights.size minus 1 and column is equal to 0. Then we create a cell which is of row, column, true and true. Otherwise, if row or column, if the row is 0 or the column is 0, then we create a cell which is row, column, true, false. If the row is equal to heights at 0.size minus 1, or actually this is column, heights.size minus 1, or column, then we create a cell, row, column, false, true. And otherwise, we just create a cell which is of row, column, false, false. So if it is in 0, size minus 1, or size minus 1, 0, then we know that it can hit both of them because they're in the corners where the Pacific and Atlantic meet. If the row is 0 or the column is 0, otherwise, then we know that it can hit the Pacific Ocean, so true, false. If it is in the row, the last row, or the last column, then we know that it can hit the Atlantic Ocean. And otherwise, they're pretty unknown, right? So now, after that, so this is an O of m by n operation in order to recreate our matrix, but now using our specialized cells that we can then use to, oh, this is part of it too, that we can then use to to run our BFS, right? So val q is equal to, let's create a linked list of cells. And actually, we don't necessarily need this. We need our matrix, we'll call it. So matrix for each row, and row for each cell. If cell.canFlowSpecific is false, or yeah, if cell.canFlowSpecific is false, then we can do a function called check can flow, or we can just do this, or cell.canFlowAtlantic is false. We can do a check flow function, which will just take the cell. And I guess our matrix too, right? The matrix will be used to check to see if we can modify, or if we can flow to any nearby areas. Then let's see. If cell.canFlowSpecific is true, and cell.canFlowAtlantic is true, then we can get a val return list is a mutable list of integers. We can say return list.add. This will create a list of cell.row, cell.column. And these should be in parentheses, not angle brackets. So this will add a list, the coordinate pairs. And then at the end we can do a return list. And then now we just need to do this, fill out this check flow function. So cell, which is of type cell, and matrix, which is of type array of cell. And we can say we will check the 4 cardinal directions, so BFS in 4 cardinal directions, to see if we can reach some sort of flow. And we're gonna have to check all 4 directions no matter what, sort of, because we don't know if there's like a sort of snaky way in order to reach the Pacific Ocean. Like, for example, let's see if there's a good example here. Trying to find a good example of like some cell that doesn't necessarily go right away towards the direction of the ocean that they need. But I'm not sure. I don't think that there's really a good example here. I mean, technically something like this, right? So we can go to the Pacific Ocean from here, or Atlantic, like going up first, then to the right. It doesn't necessarily have to be all the way to the right. So we kind of need to check in all 4 cardinal directions, I think. So we can say Hmm. Let me think how to implement this. Cell.row is greater than 0, or -1 is greater than or equal to 0. And cell, let's see. If cell.row plus 1 is less than matrix.size, if cell.call -1 is greater than or equal to 0, if cell.call plus 1 is less than matrix at 0.size, then we can say val q is a linked list of cells. Cell.row and while q is empty, and we'll just throw the not after that. And we'll say val front is q poll, and we'll have to use this terminology then. Let's see. If, let's see, can flow Pacific. Oh, and we can say, we're gonna need the height matrix too, right? Yeah, we can just toss it into here instead of recreating it. Which is an array of int array. Height at front.row -1, front.call is less than or equal to front, or heights at front row, front call. Let's see. If front or matrix at front row -1, front call dot is true, then front dot can flow Pacific is true. And similarly, if it can flow Atlantic, then we set that to true. And then we want to do q.add front dot, or let me think. Maybe a better method would be flowing from from those that already can reach the oceans into the inner part rather than flowing outwards. Let me think. I'm gonna do that instead, actually. Yeah. And then we can say, if there was a change, if front.canFlowPacific is false and this, then we can propagate it to its other neighbors. So q.add matrix at front.row -1 front.call. If it's greater or equal. So we're kind of doing a reverse flow in this case. Front.canFlowAtlantic is false, and this. Then we do a q add matrix front.row -1 front call. So the idea is create this linked list of cells actually here. Val new cell. We'll do a private late init var new cell. And then we'll set that and we can say if new cell.canFlowPacific is true, or new cell.canFlowAtlantic is true, then new cell, we add that. then we can say check flow q matrix heights. So this is the BFS call to propagate the can flows as far as they can. So now this is a cell queue, which is I think we can use the abstract type here. So now the idea is that we run the BFS starting at these tiles that can actually reach the oceans. And we can see if we can sort of move them to a new, if they can spread to a new cell, essentially. So this cell right here on the 1, well, it can spread to here and here, but those are both already touching the Pacific Ocean, so it doesn't matter. But for example, this cell right here could spread to this cell, which previously could not, right? And then this cell could spread to here and here. Right, so now these cells can touch the Pacific Ocean, and so on, and so forth. So I think that's the strategy that we're gonna go for. And heights at front.row plus 1 front.call. Heights at front.row front.call. We can pretty much duplicate this logic and replace this with +1s rather than -1s. And the idea is that we only want to propagate this change to, well, first the height has to be larger or equal, right? And it's in the 4 cardinal directions. And it shouldn't have the tag already, because if it has a tag, then there's no point in propagating it further. And then we can sort of do something similar in heights, front.row, front.call -1 is greater than or equal to heights at front row front call. And we can say if front can flow Pacific is false, and our matrix at our front row, front call -1, can flow Pacific. And we know that these front can flow Pacific is true, because we're doing a reverse now. So matrix at front.row -1 front.call. So we need to modify this a little bit, because now we're modifying those. So let's redo this part. So if our current cell can flow to the Pacific, and our next cell cannot, right? Then we want to set the next one to true, and then propagate those changes by adding them to the BFS queue. So if you can flow, we can just copy and paste this actually. And just make sure that this is row, and this is column -1. Next one here. Ooh. This is a lot of... This would be like a question 3 on a code signal test with all this typing. Okay. And we could probably like further like we could probably avoid a lot of this code reuse by just moving this into its own function as well. And I might end up doing that. Let's see. Yeah, let's do that. Update cell. Origin, which is a cell. Destination, which is a cell. We can say if origin.canFlowPacific is true and destination.canFlowPacific is false, and boolean updates a cell and returns a boolean on whether or not it was updated. And we can say var was updated starts off as false, and destination.canFlowPacific is true and was updated. It's true if origin can flow Atlantic is true and destination can flow Pacific is false, then destination can flow Pacific is true. This needs to be a set, not an equality check. And this is can flow Atlantic. And was updated is true. And return was updated. And if update cell matrix at front dot row front dot call and matrix at front dot row -1 front dot call. If this happens to be true, then cell q add matrix front dot row -1 front dot call, and now we can abstract this away and instead do this instead, and this is going to be here front dot row +1, this front call -1 front call +1. Okay, so the source, or the origin and destination, and then we need to update these as well. This should be a +1. Okay. So that doesn't need to return anything, and then we just search through the matrix after we're done with the BFS. So that should work. Let's go ahead and run the code and let's see if we missed anything. Oh, of course, this should be also a front row front call +1 greater than or equal to heights front row front call. We have a height.size on line 51. It should be heights.size. Infer type is unit, but solution cell. This is line 67. Infer type is unit, but solution cell was expected. Do I need to do like a new cell here? Because this is expecting a cell. Return list no longer exists. So let's fix that. So return list is a mutable list of integers. And let's see, return list. So that should be solved. Okay, cool. Looks like it worked for the first one. Let's try out the second example. Okay, that seemed to work. Let's go ahead and press the submit, and let's see if there are any edge cases that we need to account for, or if this is too slow. Ooh, it looks like we have the wrong answer for this behemoth. Right, this is all on one line. 0, 0, 40, 0, and 41, 0 are all on there. However, let's see. I'm curious as to why this didn't work. Let's see. Let's assume that we recreated this, right? When we recreated this, we added this into here, our queue, and then our queue we just kept on adding. Let's see if there's anything wrong with adding items within our queue. Doesn't look like it. Yeah, let's see. Row -1 is greater than or equal to 0. Row -1 is greater than or equal to... So the next cell is either greater than or equal to our cell. This is greater than or equal to 0. That seems fine. But it seems like we're only hitting... We're not hitting a lot of... we can do a print line on this. Added new cell. And looking at this, it should add all of them, right? If they're at... Oh, it's a row. It's a... Wait, no. No, that's fine. They should be able to hit both. Column is 0. Let's see. If row is 0 and column is in the corner, right, the top right corner, you try to do something different. So cell, row, column, false, false. If new cell dot, or if row dot cell, sorry, new cell dot row is equal to 0, or new cell dot row dot column is equal to heights at 0 dot size minus 1. And this is inside an if statement. Then new cell dot can flow Pacific is true. And likewise, if new cell dot row is equal to heights dot size minus 1, or new cell dot column is equal to 0. Sorry. If the row is 0, or the column is 0, and if the row is at its max, or the column is at its max, flow Atlantic is true. And I could probably put this into the construction time, or in the construction itself to make it faster, but let's see. So if the row is 0, or the column is 0, then it can float to the Pacific. If the row is at its max, or if the column is at its max, then it can float to Atlantic. So this should be correct now. And we could also say it's fine. I was gonna say we could further optimize this by doing like a size check to see if we've already started with all the cells inside the queue, but I don't think it's necessary. Looks like that's still fine, so let's go ahead and... So I think that when statement was just a little bit too restrictive in terms of like the sort of cases that we were dealing with. So this is just more of an open thing. Like if it's in the right spot, then we just change it to be correct. In any case, this seems like a perfectly fine solution. We did spend a little bit of extra time to like just make it look a little bit nicer. Abstract away some of this additional logic, which I think is perfectly fine. And yeah, so instead of running BFS from the individual cells to see if we can reach a cell that can flow to the Pacific or Atlantic, we sort of did the reverse, where we took cells that could already flow to the Pacific or Atlantic and fill it inwards to any of the cells, and then we ran an m by n. Then we ran an m by n, another m by n operation to add it to a return list. Though we could probably... that's a good question. Like, we could probably move this into the check flow as well. And then we just add it there. So then this would be probably a little bit faster still. But I think this is a perfectly fine solution. Running the BFS in that case, I mean, if it's all flat land, then it'll be, let's see, O of m by n to just do like basically a flood fill. And then since they aren't going to get iterated over again, this this might actually be pretty slow, but I'm just thinking about the runtime now, which probably isn't a good idea. But if I had to say, let's see, if I ran the m by n on a flat piece of island, then I would start by adding all the elements within there. The first cell would basically do a flood fill for all the tiles to be within Pacific. Well, it'd do a pretty slow flood fill. And that would be O of m by n. And then the first Atlantic cell would also do an m by n. Slowly. So I think we're still in the realm of m by n. And I think we're still in the realm of m by n, considering that, well, first thing is that it passed with the runtime. And it seems like the runtime is pretty standard, so. And I think that the BFS does go through m by n just like sort of in chunks. Of course, it goes like, it propagates to the first 4 cells around it and then next 4 cells and so on and so forth, right? So ultimately it does an m by n. And only adds items back if they're actually changed, which is probably a crucial time optimization thing for this problem itself. But in any case, I hope you learned something, and I'll see you for the next problem.